Dear students, welcome to EPG Pathshala. I am V.N. Prabhakar from the Archaeological Survey of India. In the paper on Principles and Methods of Archaeology, we will be discussing about the second part on the scientific tools in archaeological exploration. So we have already seen in the previous module the first part on scientific tools in archaeological exploration, and we have discussed on aerial photography, remote sensing survey and geographical information system. So in the present module, we will be discussing on the subsurface prospecting, geophysical survey and the tools generally used in the underwater archaeological investigations. The scientific tools used in the explorations are indicative only and needs to be confirmed, preferably excavations, because they cannot give a complete picture of the buried remains. So excavations are always an option to confirm the findings from the archaeological exploration. So we have different tools for the subsurface detection. They are completely buried, and so we need to use various kind of tools. It may be simple tools and they may not be complicated, and they are in the use for a pretty long period, and they are also very easy to use. It works on the principle of tapping the surface to understand the solid or hollow nature of the subsurface. This is one of the most simplistic tools that can be used to understand what kind of buried remains, whether it is hollow or solid kind of thing. If certain buried floors are there, it can be just tapped and understood by listening to the nature of the sound. The acoustics principle used in this subsurface tapping, it helps in understanding the nature of the surface, and hence a preliminary idea can be understood, and then other detailed scientific tools can also be used to probe. So one of the subsurface tools used for investigation is a T-probe. It is a very simple tool. It's a T-shaped steel rod with a pointed tip. It can be used to know the buried remains. This rod with the sharp tip can be applied on the surface at several points, and the pressure or the looseness of the earth can be very easily measured. These pressure and loose points can be marked on a map, and then a relative topography can also be developed. Wherever there are loose areas and wherever there are solid areas, it can be understood from this T probes. Then comes the auger surveys. I mean, these kind of auger surveys are again an extension of the T probe, because T probe, it cannot go very deep into the surface, and it can only reveal just the nature of the surface, just buried from the surface. But this the auger survey, it can go deep. It can be driven to very deep into the soil. We can obtain samples from variable depths of the subsurface, and also construct a kind of a stratigraphic sequence. I mean, it can be driven into very deep depths, and can also obtain samples from the deep depths, and that can be arranged on a stratigraphical basis, which can be studied and understood. What is the nature, what is the stratigraphy, what is the cultural remains a certain archaeological site may contain. So this is an extension of the T survey. So apart from the T probes and the auger survey, there are some other tools also that can supplement this kind of subsurface detection. One is the endoscopic devices, which can be used to insert into the hollow surfaces and know the interior nature of the unopened buildings and structures. These kind of endoscopic devices have been used effectively in the pyramids of Egypt, and buried or unopened buildings have been studied using this kind of endoscopic devices. And also another kind of devices that can be used is the ultrasonic sensors, which can be used to detect variability in hardness and hollowness, which can be again mapped. These ultrasonic sensors very easily detect the hollowness or the hardness behind a wall surface or the beneath the floor surface, which can be mapped, and a relative topography can be developed. So this is both useful for structures like the pyramid, as I told, are unopened wall surfaces where there is no evidence of any door or window. The behind what kind of remains are there, that can be very easily measured, and also archaeological floors which may be hollow or solid that can be easily detected. And next comes the geophysical survey of archaeological site. These are based on the geological applications. First, we have seen very simple tools, T-probes, auger survey, ultrasonic, and other sensors. But here we are applying a different area altogether, because geological applications are also very much useful in archaeology, and there are various tools in geology which has developed that can be used to detect the subsurface features. These geophysical surveys, they are totally non-invasive and non-destruction. So it is completely helpful for the archaeologist to probe, and they can cover vast areas for detecting the subsurface features. They can also help in the detection, imaging, mapping of surface features over large areas in potentially great detail. So there are various tools which we will be seeing one by one what kind of tools are there. But there are certain disadvantages also, even though it can give a large advantages, but there are certain disadvantages also, because these geophysical tools, they work based on the nature of the soil conditions. If there are loosely buried features like stone debris and compact soil conditions mixed with archaeological remains, it may not give a better feature. So these are some of the disadvantages which has to be kept into mind, and always we need to take a note of this kind of features before carrying out a survey. The geophysics tools, it is one among the multi-dimensional approach and not the only aid. It has to be kept in mind actually. Geophysical tools, they are combination of several tools. We will be seeing one by one. So at the end of the thing, we will be understanding how different tools have to be combined together instead of only relying upon one tool. Again, these geophysical tools can be divided into passive and active methods depending upon the technology that is used. The passive method technology consisting of magnetic prospecting, and then gravitational surveying, and self-potential techniques. These are the three techniques we will be looking into one by one, and among them the self-potential survey is considered to be the least expensive method in detecting archaeological survey. So now we will be looking into one by one. The techniques are, under the active methods are seismic or acoustic, electromagnetic, resistivity or galvanic, and ground penetrating radar. So these are the various methods under the active and the passive methods. So coming to the seismic or the acoustic, what kind of methodology is used here? Acoustic we have slightly looked into earlier also, how the sound tapping reveals a general idea of the buried features. But here we are using certain geophysical methods which gives a certain advanced imagery of the buried features. So this method involves transmission of sound waves and measuring the time of reflected ones based on the density variation of the buried features. If a sound wave is allowed to pass through the buried features, depending upon the density, variability in the density, these sound waves reflect back strongly or loosely based on the physical properties of the buried features. So the relative movement of sound waves through harder and softer archaeological deposits, it can be measured with the aid of suitable equipment and mapped to understand the nature of the buried remains. So this is one of the method used for the geophysical investigations. One more method is the electromagnetic method. This is based on the non-conducting electromagnetic or induction method, which ranges from simple metal detectors to sophisticated soil conductivity meters. I mean, as you can see in the figure, you might have observed how the metal detector work. It detects any presence of any metal from any surface, and this same principle can be used to slightly measure the metal content of buried archaeological deposits, not very deep but very close to the surface, that can be very easily measured. So these simple metal detectors have been used successfully in many of the European countries to even detect large coin hoards, even Roman period and Celtic period. Metal remains have been very easily found using a metal detector. The next comes the electromagnetic method. In the continuation of the electromagnetic method, the magnetic surveys are particularly suitable for buried fired clay structures. I mean, like example, in the ancient period, the humans they have used fire to make bricks, pottery, walls, furnaces, pottery kilns, hearth, anything associated with the heating of the surface which has hardened over a period of time. They are fired to around 700 degrees centigrade. So they are suitable for detecting under these magnetic surveys. The magnetic surveys, they work on the principle that minute quantities of grains of iron oxide, they are present in the clay. I mean, the clay in the natural way, they contain iron oxides, and they are randomly oriented in unfired condition. But if they are heated to around 700 degrees centigrade, they become aligned to the Earth's magnetic fields. So this is the basic principle applied, and this alignment can be measurable using the suitable equipment for detecting the subsurface features. Again, this can be mapped, and again relative presence of harder or softer surface can be very easily understood. One more method is the resistivity or galvanic method. This is based on the electrical conductivity, works on the principle of conduction or non-conduction of electricity by the soil. Again, depending upon the nature of the soil, the compactness, the conductivity, electricity can be conducted very easily, or it can be blocked by the soil conditions. So it also depends upon the moisture content of the soil. If the soil is more moisture, damper, so it conducts more electricity. So these kind of features can be used, and also we have to measure, we have to understand whether the soil is moist or not before carrying out the electricity resistivity survey, because if the soil is more damp, it is not suitable to conduct the survey. It will give a altered view of the subsurface feature. So this is indicated, the subsurface feature is indicated by this conduction and non-conduction of electricity. The normal methodology is by injecting current to the surface with the aid of electrodes, and the potential difference between the electrodes are measured, and mapping again is done where the relative presence of conductivity and non-conductivity, and it will lead to a mapping of the buried features also. Next comes the ground penetrating radar. This is one of the most suitable techniques used by many of the archaeologists and even by the geologists. They use for detecting the subsurface features. Even the geological deposits can be measured here. It is a tool ranging detection between a few to several meters beneath the surface. It can, depending upon the antenna what we are using, so even buried features ranging within a few from the surface to several meters can be detected using this principle. So it works on the principles of transmitting different wavelengths of electromagnetic waves, and then measuring the continuity or discontinuity of the reflected signals. Because the waves penetrate the surface, it goes there, it strikes any compact surface or any wall or fallen debris. Then if there is more compactness, it is reflected immediately. If there is no compactness or no buried features, it goes on and then strike backs and come back. So depending upon this variability, we can measure, and then again we can detect the anomalies. So it generally consists of like a wheeled carriage like this, and the antenna, different wavelengths of antenna, they are used for a variability of different depths. So this can be used, and it can be moved on a surface continuously. Then it can be directly connected to a surface on-field monitor, and then the recordings can be made in the inbuilt memory chip, and then after coming back we can transfer this data into a computer, and then several post field survey processing has to be carried out to remove the distortion, to remove the anomalies, and then the results can be understood for better interpretation. So this is one of the very good tools, and one of the drawbacks of this tool of ground penetrating radar is that it's very slow, because it has to be moved very slowly on a surface where the investigation has to be carried out, and a lot number of a few people have to be required for moving the antenna, drawing that, pulling that, carrying the on-field monitor. And also, if we want to make a very detailed 3D reconstruction, a grid pattern has to be developed, and we have to move this radar or the antenna in a crisscross manner. So it takes a lot of time. However, this is one of the very good tools in the absence of any other suitable technology, and if it is combined with other techniques like the electrical resistivity and the magnetometer, the results can be really good. I mean, the picture shows some of the investigations carried out at Dholavira. So now we study some of the case studies actually. I mean, using these techniques, wherever archaeologists have used these tools, we will look into. One such site is Ahichatra. It is located near Bareilly. It's one of the important sites, a huge site measuring nearly 1.5 kilometer east to west and again 1 kilometer north to south. Here, in collaboration with IIT Kanpur, the Archaeological Survey of India carried out ground penetrating radar. If you can see, there are 3 or 4 locations here it is shown. We will be discussing about the results of the westernmost investigation site, which has revealed a fallen debris actually, and that has been very well reflected, and which is very easily detected in the excavation also. So you can see in the adjoining slide, one is the ground penetrating radar results. You can see the slump. There is a slump there. There's a red color. There's a slump there. So when this result came, to confirm the results of the ground penetrating radar, immediately an excavation was carried out. You can see again there is a brick wall slump. So this is a very good technique actually to have a broad-based understanding of the location of structures. If there are buried plans of structures, it can be very easily done also. And with the availability of modern technology, we can have a very good idea of even where to excavate, because selection of a site to excavation is very, very important. If we have tools like this, we can at least know where the structures are there, where the habitation is there, then we can select a proper site. The next case study is from the Lothal revisitation project. It's a project again approved by the Archaeological Survey of India and carried out by the University of Bologna, engaging a large number of multidisciplinary sciences. They combined with remote sensing and field activities, they use non-invasive geophysical techniques to understand the buried features. So what were their objectives? They wanted to understand the natural and artificial subsoil features complemented by a series of core drillings to determine the shifting of paleoceans and shorelines. As you may be knowing, Lothal, it is one of the earliest dockyard sites in the Indian subcontinent, datable to the Harappan period, where during different periods the dockyard was used depending upon the high and the low tides and shifting of the nearby river water into the dockyard. So in these investigations resulted in the detailed understanding of the sites also. So the investigations at Lothal, it was used with a magnetometer survey, and it revealed very interesting features. You can see it's a baked brick embankment canal running east to west and perpendicular to the dockyard. So this is a very important evidence that a canal is feeding the dockyard, connecting the Paleo River, and an architectural complex consisting of rooms along a narrow street and separated by lanes. So you see, even the layout of a small area of the habitation can also be understood, and a possible monumental gateway with a large drainage outlet to the southwest corner of the Acropolis. So these 3 anomalies have been measured using the magnetometer survey, and one of the investigators, Frenes, he carried out test trenches in the areas of anomalies, which largely confirmed the findings. So this is how it works. I mean, we do a survey, geophysical survey, then confirm it with excavations, because without excavation we may not understand whether it is actually there or not. So this is one of the important features of the geophysical survey, and in the next slide you can see the results of this geophysical survey at Lothal. You can see this is the area of investigations, and wherever the anomalies have been detected, it has been shown, and the trench locations are also shown where the confirmation of the geophysical survey were also obtained. So the next case study is from Dholavira, where in collaboration with the Archaeological Survey of India, the IIT Gandhinagar, they carried out ground penetrating radar survey. In the area to the east of the East Reservoir, you can see the different areas that has been marked in different colors that has been shown, and they were probed, and the results, they indicated very interesting details, because the eastern reservoir, it is connected to the Manhar River, located to the south and southeast of the settlement, and from there various feeder channels, maybe diversion of water into these reservoirs could have happened. So these ground penetrating radar results also indicate various features, anomalies located to the east of the east reservoir, indicating parallel walls, smaller tanks, and which clearly indicates there are buried features. But here the excavations could not be carried out. And the next slide you can clearly see the area actually of the detail of the area from where the investigations have been carried out. The yellow rectangle indicates the east reservoir, and towards the east of that the larger area where the investigations were carried out, and to the northeast you can see the Manhar river. So this is the area which was excavated, and the next slide you can see the results here. You can see the results here where the parallel walls have been indicated, maybe a feeder channel coming from the river to the eastern reservoir is also indicated. So broad-based findings clearly indicate the presence of buried features, probably stone masonry walls, parallel walls indicating rectangular or square tank features like features, and some feeder channels. Now we come to the last part of this scientific tools in the archaeological investigations. That is about the underwater archaeology. Underwater archaeology is one kind of approach for understanding the archaeological remains buried under water. It may be under a lake, it may be under a river, it may be under the sea. So wherever there is water and wherever we suspect there could be some buried underwater archaeological features are there, this can be investigated using underwater archaeology technique. Basically, it is also archaeology, but the tools and implements used here are slightly different and varied from the normal archaeological investigations. So here what happens, one has to survey a very large area. Again, it is very cumbersome when compared to the ground survey. Here one has to use different techniques for surveying a very large area and a small area. Different types of approaches are adapted. One is the towed drive search, and the swim line search, or a free line search, offset method, and jack stay. These are the four methods. We will be seeing one by one what are these methods. You can see in the tow driver search, a diver towed with a small boat moves over a pre-decided area for search of underwater remains. The illustration also indicates how a diver moves over a pre-decided area and searches for the archaeological remains. Again, it is very time consuming and cumbersome. The next one is the swim line or the free line search. Here 3 or 4 divers, they move parallel, parallel among each other, and they search a very large area. Again, you can see this can be done, a large area can be covered by 3 or 4 combined divers, and the location is marked on the surface, directly marked on the surface. So this can be mapped. The location can be mapped by using floatable balloons known as buoys. So that can be used to understand the location where the divers are searching. So next one is the offset method. Again, it consists of positions in relation to jack stays and ground lines. They fix the ground lines and the jack stays on the surface, and then they understand the various kind of the underwater archaeological remains. Again, it is consisting of 2 or 3 divers, they moving in an area. The last one is the jack stay or the corridor search. Here, area is defined. Maybe rectangular, the square area is defined. Again, on the surface it is indicated by buoys, and then within that area the search is done for documenting the archaeological remains. So these are all manual searches. Manual searches are always time consuming, and it may be prone to error. In the consecutive slides we will be seeing about what kind of again techniques, scientific tools that can be used for investigating the underwater archaeological remains. So one such is the echo sounders. Again, it is based on sound waves, like in the ground survey what we have seen. The sound waves are the sonar, or the sound waves are emitted in the pulses into the water, and they are reflected back from the surface, tracking the surface. So the time taken between the emission of the pulses and the reflected ones is measured, which enables to measure the depth of the water and also the speed of the sound in water. So this can be used to understand a relative bottom profile of the buried archaeological feature. So if there are certain ship remains or shipwrecks buried on the seabed, so the relative variability of the sound waves reflected from the seabed can be used to understand the buried feature. So one more advanced technique is the multi-beam swath system, because the echo sounder, it is very consuming, because it is only emitting one ray of the sound beam. But here it is covering a very huge area, wherein a single beam pulse is replaced by emission of multi-beam pulses. So large number of pulses are emitted, so they can cover a very big area, and a swath of the entire seabed can be completed in a very fast time period. And these several swaths can be undertaken by a boat or a ship moving on the surface, sea surface. So this can be done, and multiple recordings are possible. So effectively, we can see, as in the adjoining figure, we can very easily cover a very large area. So one more method is the side scan sonars. This is again an advancement of the acoustic technique, but again what happens here is that the underwater imaging is carried out using a wide angle pulse, meaning it is again similar to the multi-beam swath system, but in addition to the multi-beam swath system, a tow fish consisting of sonar equipment is dragged over the sea floor. So this is a combination of two techniques. One is the multi-beam swath, and addition to the sonar equipment which is dragged over the sea surface to have a imaging of the sea floor in the in a broader sense. So these two combined techniques, it gives a better image profiling of the seabed. Again, if there are certain features buried or even lying on the surface, this can be very easily detected using these kind of systems. The next one is the sub-bottom profiler. I mean, whatever we have been seeing before, it can only detect objects lying on the seabed or lying on the lake bed or wherever it may be, because it will give the variability of the depths of buried objects lying on the floor, and the variability of the time taken for the sonar waves to come back to the receiver. It will give the bottom the buried the features lying on the seabed or the lake bed. But here what happens, the sub-bottom profiler, it is similar to the echo sounder, but instead of mapping the sea floor or the lake floor, the sound waves penetrate the surface, like in the happening of the ground penetrating radar. It slightly penetrates the surface also, and depending upon the buried strata or archaeological remains or rock debris, everything, it can be used to map the buried features also. So this is an advanced system. And the last one is the integrated survey. Here it's a combination of various techniques, various equipment used in a single point of, like a magnetometer, side scan sonar, sub-bottom profiler, remotely operated vehicle, which is known as ROV. So everything is combined in one integrated system by a large vessel or a large ship or a medium-sized ship. So it can be used to cover an entire area, and all the data can be integrated. This can be used to simultaneously record also videography and photography, and from the ground itself also one can really control the entire survey. I mean, this kind of advanced systems have been used to even detect large shipwrecks, like even the Titanic is one of the famous shipwreck. It was lying nearly 2000 meter from the sea surface in the Atlantic Ocean, but this kind of advanced exploration techniques for the underwater archaeological remains, they have been used to find the buried and as well as the remains lying on the sea floor or the lake floor, wherever it will be, it can be easily detected. So to sum up, there are various kind of scientific tools which with the very simplistic T probes to the auger surveys to the sophisticated magnetometer survey or the geophysical survey, which have been used on the ground penetrating radar. So these equipments, some of them are very simplistic to use, but some are nearly very costly and requires dedicated manpower for that also. For example, to use a ground penetrating radar, it is very difficult. One has to have a real expertise in using the ground penetrating radar, do the survey, then get the anomalies, then do the post survey cleaning and interpretation. So this consumes a lot of time. So one has to have an experience in operating the system and also understanding the anomalies. So it is both expensive and need a lot of expertise to operate. So nowadays we have in India these kind of equipments. Many of the scientific institutions, like I told you, IIT Kanpur is having a ground penetrating radar, even IIT Gandhinagar has a ground penetrating radar. So instead of archaeologists acquiring these kind of sophisticated equipments, they can collaborate with these kind of scientific institutions, and they can involve them and do a lot of research. And this data collection as well as in the laboratory also takes a lot of time, as I told before. So it is done by only specialized people doing a lot of research in this area. Similarly, underwater archaeological investigations also, it requires a lot of expertise, divers having suitable experience to dive in certain environments. So all these kind of things are there. So you can also read the other components of the module to understand the various scientific tools used in the archaeological exploration. You can read the e-text and also the references to have a further understanding. Thank you.